So right now in this video, we're going to learn about acute inflammation. Okay, so previously I just stopped in this topic, acute inflammation. So what do you mean by acute inflammation? So acute means sudden, okay, sudden in onset. So acute inflammation is sudden in onset. And remember the major difference between acute inflammation and chronic inflammation is that acute inflammation does not follow repair, okay? So there's an inflammation, but there's no repair in the case of acute inflammation. Chronic inflammation, there is inflammation and there is repair. Now you might be thinking, what is repair? For example, you just got a cut in your hand. Suppose this is your hand, you just got a cut and there's abundant amount of bleeding, okay? Now what happens is there's a certain amount of inflammation over this area, and later on, as a part of your repair, there is first of all aggregation of platelets, and you have a like a type of a clot formation here, okay? And after some time you will see that the skin is also intact. Now this after a scar is formed later on, a temporary scar, and then now it's the scar is completely removed and there's your actual skin, okay? So that is actually referred to as chronic inflammation. There is an inflammation and there's a repair. This is actually something a bit different than what I'm talking about in chronic inflammation, but just as to explain you in the best way possible, I'm just giving you this one, okay? Rather, chronic inflammation is always follows repair. That means there is fibrosis. There is fibrosis in the end stage, okay? In the end stage, first of all, there will be inflammation, and later on there will be fibrosis, which is the end stage, okay? Remember, chronic inflammation is always supportive towards macrophages. So every chronic inflammation is associated with the macrophages. And when we talk about acute inflammation, it is always associated with the neutrophils. So the neutrophils will be the sole leukocytes that will be acting over in acute inflammation, and in chronic inflammation it would be the macrophages. Remember the difference between monocyte and macrophages, which is a very important aspect, okay? Macrophages. So monocyte is basically when it comes from the bone marrow, it's known as monocyte, and when it goes to a tissue, it's known as macrophages, okay? Now in acute inflammation, the very, very important aspect is the vascular events and the cellular events, which I'm going to talk about right now. So one is the vascular event, other one is known as the cellular event, okay? Now, what do you mean by vascular? What do you mean by cellular? So see here, vascular means, for example, what happens is when you have a cut, suppose there's a cut or an injury, this is your hand, there's a cut or an injury in your hand, there's a cut over here. Now what will happen? Now the blood vessels supplying this particular area, the blood vessels which supplies this particular area will initially shrink. Initially, it will shrink. Now that shrinkage of that blood vessel is brought about by two components. One is endothelin and other one is known as secretin. One is endothelin, other one is known as secretin. So basically this is your blood vessels. This is the area where you had a cut, okay? Now this blood vessels will actually shrink. It will go smaller. Very, very small. And when it becomes smaller, and this is your cut, okay, when it becomes smaller, then the blood supply to this area will actually decrease. And the major aspect to decrease the blood supply to this area is actually we don't want much bleeding. Much bleeding avoided or prevented. That means to decrease the extent of bleeding, there is release of endothelin and secretin. Okay, endothelin is actually released by the endothelial cells, which lines the blood vessels. Suppose if this is your blood vessel, then there is this cells, beautiful cells, which is known as endothelial cells, and these endothelial cells only they secrete endothelin. Other components are also there, which is secreted by the endothelin. One very, very important component is NO, nitric oxide. This nitric oxide basically it is basically important for vasodilation, and it is important for anticoagulant property. And this basic property we'll study in one of the diseases, one of the pathological condition, which is known as thrombosis. In thrombosis, we'll come to this in more detail. Right now, just remember that endothelin is released by the endothelial cells that lines the blood vessels. That brings about shrinkage in the blood vessels to reduce the extent of bleeding. Okay. The second step would be vasodilation. Now you might be thinking, which brings vasodilation? We initially talked about vasoconstriction, which was brought about endothelin and secretin, but now we are talking about vasodilation. And what brings about vasodilation? Vasodilation is actually brought about by histamine. Okay, histamine. Don't be confused with this NO. Okay, this NO is not actually responsible for vasodilation. Here, the major agent for vasodilation is histamine. Okay. Don't be confused with this one. This was just for your note or a short information. So yes, we have histamine now, and this histamine is responsible for vasodilation. And we have one more component which is known as VEGF. Okay, this VEGF, this is known as vascular endothelial growth factor. Endothelial growth factor. VEGF, vascular endothelial growth factor, is responsible for actually creating spaces. For example, if this is your endothelial cells which is being compacted in this area, what happens basically is the endothelial cells will get separated. It will get separated. Like there's a slight separation in between these two cells in this way. And why is this important? I'll tell you why. See, now what happened? First was vasodilation. Second was shrinkage of the endothelial cells to create spaces between the endothelial cells. And this is actually important for coming out, for releasing, actually I would say you just look into this diagram, okay? For releasing of the exudate. Now these exudate are actually protein-rich fluid. And when these exudate are intercollected in this areas, now here there will be a lot of fluid, right, which is coming out. When there will be this event, there will be swollen aspect, like it will, the thing will look swollen. Okay, for example, if you have a injury in your feet will be swollen. In your hand will be swollen in that way. Okay, next, very important, again very important. Remember, this was actually the vascular event. The vasodilation, shrinkage, that was vascular event. Now I would come to one of the most important mechanism. Very important, okay? Remember that whenever there will be this action, and one more thing I would like to talk about here is one term, transcytosis. Transcytosis is actually, the removal of this. I wouldn't say removal, actually it would be better, I would say transport. The transport of the fluid from the intervascular space to the interstitial space. So this is the interstitial space, okay? And that is known as basically transcytosis. Now why was this important? This was important to bring about stasis. Now what is the stasis? Remember, our blood is in the laminar flow fashion. What does that mean? Laminar flow fashion means the RBCs are in the middle, okay? Then the WBCs, then you have the platelets, then you have the plasma in this manner, okay? This is known as the laminar flow of blood, laminar flow. And whenever there is stasis, that is slow flow of blood, stasis means slower, what happens is these WBCs, which was, very close centrally, will now come close towards the endothelial cells. Suppose this is your endothelial cells. These WBCs, this beautiful WBCs, okay, I'll mark with a different color, okay, black color. These WBCs will come near to the endothelial cells, and this process is known as margination. Remember which type of WBC would be the question. Which type of leukocyte would be the question. The answer to that question is neutrophils, because we are talking about acute inflammation. Is that clear? Okay, next. So that was known as margination. So suppose this is your blood vessels, and then you had your WBCs over here. Now what happens is, actually, this is a man, he rolls down, he goes down, he sleeps over here, again wakes up, again goes down, sleeps over here, again stands up, and again goes down. Okay. Now this action is similar with the WBCs. Similar with the WBCs. So what will happen? WBCs will go down. It will again stand up, go down, again stand up, go down, and again stand up. And this process is known as rolling. Rolling. Okay. Next is actually adhesion. Okay. So adhesion is brought about by two components. One is the selectins, other one is known as the integrins. Now how do they perform? See, I'm making this video so concise so you can write in the examination, and if you just study the Robbins now, after this video you'll understand everything. I've intaken a lot of components from Robbins, and I've been teaching you these things from Robbins. Okay, so see here, there is three types of selectins. One is p-selectin, L-selectin, and p-selectin, L-selectin, and E-selectin. Okay, remember one more thing, that this p-selectin is basically found in the variable palate bodies. Okay, variable palate bodies, and the expression of the selectin is basically moreover related to histamine and interleukins. Moreover, interleukin 1. So whenever these components are released, these selectin will be released in this way. It will be released in this way, like this. And these selectins are p-selectin, L-selectin, and E-selectin. P-selectins are present in your platelets. E-selectin are present in your endothelial cells, and L-selectins are basically present in your leukocytes. Okay, L-selectin are present in your leukocytes. Now, remember that they will be attaching towards this endothelial cell. Suppose if this is you have a beautiful diagram in this Robbins, you can refer to that also. You have this endothelial cells over here, and then you have this selectins. The WBCs will come and attach here. It will again roll, again go up here, again attach here, again it will go somewhere here, again it will attach to this one, and that was basically known as rolling, which I was talking about. Now I don't want this. I want a fixed adhesion. And that fixed adhesion is brought about by integrins. And integrins are the ones that brings about fixed adhesion. Okay. So what happens is, after this rolling process, the fixed adhesion is brought about integrins, and there are different type of integrins like ICAM, LCAM. Okay, ICAM binds to LCAM. ICAM is basically intercellular adhesion molecule 1. Okay, intercellular adhesion molecule 1, which binds to the leukocyte function associated antigen 1, or it is also known as macrophage 1. Okay, macrophage 1. And the next component is known as VCAM. VCAM is basically vascular cell adhesion molecule that binds to very late antigen. So V for vascular and vascular cell adhesion molecule, and V for VLA. Okay, that is very late antigen. So V attaches to V. Okay, ICAM, LCAM. Remember, while writing L, you just write it in this way, right? Wait a second. You just write L in this way, right? Okay, I just put this one. So what would this be? I. So LCAM, ICAM. That would be a basic way of remembering. Okay, that is brought about by integrins. Now let's come to this process, which is known as diapedesis. Wait a second. Diapedesis. Okay, yes. Now what is this diapedesis? Or it is also known as diapedesis, or it is also known as transmigration. What does that mean? Transmigration or diapedesis? Diapedesis or transmigration is brought about by PCAM, that is known as platelet endothelial cell adhesion molecule. That means these endothelial cells, see here, okay, these endothelial cells which became completely attached here, now will move again to the intercellular space, interstitial space. So this leukocyte will come here, And here there are certain bacteria and microbes. This leukocytes will engulf them by the process of phagocytosis. Okay, and this movement from this space, intervascular space, to the interstitial space by the help of PCAM is known as diapedesis or transmigration. Clear? Remember, the movement of leukocytes from here to the areas of the microbe is brought about by three components. What are these three components? Never forget it. One is N-formyl methionine, which is a component of the bacteria. Next one is known as C5a, which is a component of the complement system. And the other one is LTB4. LTB4 is actually a component of the leukotrienes, which we'll be talking about in the another section about prostaglandins and leukotrienes. When we talk about prostaglandins and leukotrienes, we'll be talking about this section. Okay. For now, I talked about the vascular and the cellular event of acute inflammation. In a nutshell, I'd like to revise very quickly with this particular thing that I've made so far. Acute inflammation is referring to sudden in onset, and it's only involving the neutrophils. Chronic inflammation, it's associated with repair, and it's associated with macrophages. You have a cut. In chronic inflammation, there will be repair and there will be fibrosis. Repair is brought about basically by the fibrin filaments, okay? And remember, we had the vascular event and the cellular event. Vascular event, first event was transient vasoconstriction, which was brought about by endothelin and secretin. Next was vasodilation, which was brought about by histamine, okay? There was a shrinkage of the endothelial cells, which was brought about by VEGF. The movement of the fluid from the intervascular space to the interstitial space was known as transthyrosis. That's basically an exudate. That's a protein-rich fluid. And because of this, there was something which is known as stasis. That means the laminar flow of blood was now it was associated with the WBCs now went close to the endothelial cells. And when that WBCs went close to the endothelial cells, that was basically known as margination. Remember, after margination, there was expression of certain components like selectins. And when there was selectins, there was rolling. Rolling was WBCs were here. It goes down, it's again stands, it goes down. But we want fixed adhesion, a fixed adhesion. And for that fixed adhesion, we had integrins. That integrins brought about fixed adhesion. Remember that integrins were ICAM and VCAM. ICAM attaches to LCAM. VCAM attaches to VLA or very lead antigen. Okay. Next process was diapedesis. That was the movement of the WBCs, basically the neutrophils, from the intervascular space to the interstitial space, which was brought about by PCAM. Okay, and that process is known as diapedesis, or a synonym for it is known as transmigration. Don't confuse with transcytosis. Transcytosis was basically the movement of fluid, but transmigration is the movement of leukocytes. And the movement of that leukocytes towards the bacteria was brought about by three agent, N-formyl methionine, C5a, and LTB4, which we'll be talking about more in the videos prostaglandins and complement system. Okay, so for now, this was all. This is Priyam Sigdal's channel. Please like and subscribe if you like it, and please support.